And we're back. Oop, we gotta move that up a little bit. Now you can see me. Well, now it's frozen. Now it's unfrozen. I don't know why it does that, but hey, we're dealing with it. So, hi, how you doing? Missed you. Still miss you. Miss you every day. But at least we get to spend this time where you get to see this wonderful face with growing a little beard action, not going to shave as long as I'm under quarantine. My wife's not liking the hair that's growing on the top of my head because I'm not doing anything until we're out of this quarantine stuff. So here we go. We are on day 2 of navigation. And so we're going to do this ship example today. And then your homework this evening is going to be these 2 work problems at the bottom of page 3, and we're going to do those. And so here we go. A ship is heading due north at 24 knots. The current is flowing from the southwest at 8 knots. Find the actual bearing and the speed of the ship. Okay, fantastic. So that's our setup. Let's get at it. So we got the ship over here. So the ship is traveling due north. So it's going straight up. Okay? That's awesome. When stuff's happening, either due north, due west, due east, due south, when it's all that's great for you because it's traveling at 24 knots. So that means that the ship has a vector of 0 because it's not going horizontally at all, comma 24 because it's going straight vertical. Boom. Done. Love it. Okay. Then we got some current going on. Okay. So it's flowing. The current is flowing from the southwest. Well, this is west, this is south. So there's the southwest, so it's flowing from the southwest, which means it is flowing to the northeast. Okay? So it's flowing from the southwest, which then gives us, gotta switch colors, gives me a trig angle. We're going to assume that it's going directly there of 45 degrees. Okay. So that's 45 degrees in there. So that's my trig angle. So in this case, it's going to be my vector W, because it's wind or current, is going to be, well, what's the speed of that? 8 knots. So that's going to be 8 cosine of 45 degrees, 8 sine of 45 degrees. Okay? So we can go to a calculator. So here's my 8 cosine of 45 degrees, and we're going to store that one as C. Okay, and then 8 sine of 45 degrees should be exactly the same, but we're going to store that now as D. Love it. Okay? So this vector, let me throw that back on the old big screen. So this vector is, I forgot to write them down. .657. really, if I wanted to make them exact, those are both 4 square roots of 2, because the sine and cosine at 45 degrees is the square root of 2 over 2 times 8 is 4 square roots of 2. So, but that's my vector W. Love it. Okay? So we need to find the actual bearing of the ship and the actual speed of the ship. So that's going to be A plus W is going to equal G. Okay? So that's going to be 0 plus 5.65 is going to be 5.657, comma 24 plus 5.657 is going to be 29.657. Okay? So that's my vector G. Now I need to find the magnitude of G, square root of the horizontal component plus the vertical component gives me a speed of yada yada da da da. So that's going to be the square root of C squared, because that's going to be 0, and that's going to be that one, plus D plus 24. Oh yeah. Quantity squared. It's going to give me an actual speed of 30.19, let's call it 2 knots. So that's my actual speed. Ooh, didn't get any less squeaky in the time that it took to make this one. Okay? So this vector G is in quadrant number 1. Okay? So the angle that I find is going to be that angle right in there. So that's going to be the inverse tangent of 29.657 divided by 5.657. Okay, so that's going to be that, and that is going to be, back to the old calculator, trig inverse tangent of, well, let's make it a fraction, let's make it fancy, D plus 24 all over C, and that's going to be that, but again, I'm in radians. Convert it. If your calculator is in degrees, you don't have to do this. You should get exactly to 79.2001 degrees. Come on. There it is. Okay. So 79.201 degrees. Love it. But that's this angle right in here. So really, let's put it up there more. So that's this angle there. Okay. So my bearing, my actual theta, is going to be 90 minus that 79.201 degrees. So my actual angle, my bearing, if you will, move this over to this side now, see if that is going to be 10.799 degrees. Yeah, I think you can read that. Okay. Hey, least it's not backwards like it was on that video a couple of videos ago that people would give me a lot of grief for. Madus, I'm talking to you. Okay. All right. So there you go. Now, what I will tell you is this week, Thursday, we are going to have three problems, three examples, if you will, that we are going to work through live starting at, I gotta look at my times here now. One, I believe Mr. Roth or Mrs. Hill is going to do at 10:30. And they're going to work through them and then answer questions afterwards for an hour. Then the other one's going to do from 2 to 3. And then I am going to do a special session from 7 p.m. to 8 p.m. on Thursday night. Because we all know you guys are teenagers and you're probably working more along the lines during the evening than you are during the day. So we get it. We're going to offer those three examples. We're all going to do the exact same three examples on each of those three time slots. And so then we're going to work through those examples, talk more about this kind of stuff, talk more about multiple forces to get you kind of thinking towards next week when we take the test on vectors. Okay? So that's Thursday. That's coming up this Thursday. We're always available via email. You can shoot me a text if you need to shoot me a text. So yeah, we're here for you. Have a great day. Stay safe. Wash your hands.